Hello, in this lesson, we're going to talk about parametric graphing and parametric curves or functions, okay, graphs. Okay, what is parametric? What is parametric? Okay, so let's start with what it is. What is it? Okay, previously when we graph, right, we usually have a function, right? We have a function called f of x equals to whatever, okay, it's defined. And we also have, sometimes we use y equals to f of x, and the input is x, right? The output is f of x. And these are usually numbers. They're given as constants, right? For one x value, there's a y value. Okay, but now with parametric, it's different, right? So in the situation, let's take an example we have for the kind of graph and curve we had before, right? Example. Right? Example, say we have a function y equals to f of x, right? This function is x squared. Okay, and we can make it more complicated, right? So each point, okay, each point we have, if you look at the points we could plot. Okay, I think this will do it. Okay, if you look at the points we can plot, right? For example, we plot the point when x equals to 2, y equals to 4 for this point. And if we mark that point, right? So let me make a little adjustment to the view and say that should be enough, right? And we can mark this point. This point is, it's just 2, 4, and we can mark that point at something like that. Okay, so if you mark each point, and you will see that 2, 4. So x is when x equals 2, y equals to 4. And each point can be marked by 2 numbers that are set. Okay. Parametric, however, is different. Okay. Example of parametric. Okay. In parametric, we'll be able to do the graph, but there's an input, there's an output, right? You can see each point we have here is input output, right? X, y. X, y, and each number, X is a constant, Y is a constant once they're fixed, right? They're fixed. For parametric, however, X may be dependent on a function that's relying on time, and y relying on another function, which is t. So this means a function, this is another function. And these two together makes the point, x, y. So x is one function, y rely on another function. So each one is a function. So this is a function, and this is another function. Okay, so input is a function, output is also a function. So that's how we plot the points. Okay, so take an example. Okay, so let's put this is parametric, right? So no longer that x, y are constant. They're going to be they're going to be dependent on a function, which is x of t, y of t. Okay, this is still the input and that's still the output, but input depends on time, and Y depends on time. Output depends on time also. Okay, so with that said and done, let's look at an example here. Example number 2. Okay, so typically we would write these kind of parametric equations or parametric function, excuse me, in the following form. Okay, and this is the form. It could be, let me just write you the form. It could be x sub t, right? X equals to x sub t, x of t, and y is equals to y of t. So they're putting together. And of course, we're going to specify t, and t could be just time. Okay, it could be time. So for this, we're going to see an example. This example is like this. Okay, so suppose we have an example here. And this example says x equals to half of t. Half of t. Okay, and y is equals to t minus 3, provided t is time. Okay, so when we plot the graph, right, instead of just doing a table like in this case, right, when we did table, when we did the graph for y equals x squared, we just have to make a table for, say, I'm going to make 3 columns, number of rows, right? I would be making a table. On this table, it's just going to be, x value, y value, right? F of x, right? Y equals to f of x, which is y, and you put the input output together, right? And you can choose a bunch of numbers, -2, -1, 0, like we did before. And then we get numbers on this side, right? Like we used to. So this is going to be -2 squared equals to 4, and so on and so forth, right? So let me just go on with that complete table. -1, so this is 1. So this is 0, right? 0 squared is 0. 1 squared is 1. And 2 squared is 2. It's 4, sorry. So we got a bunch of points, right? So -2, 4, -1, 1. So we get these points. Okay. 0, 0, 1, 1, and 2, 4. Okay, so we can plot as many points as we want, and we put these points one by one on the picture. So I'm not going to do it in detail. However, for this new kind of function, we're going to make our table a little bit more, okay, because we have an extra t. Okay, x depends on t, y depends on t. Okay, so we have a t as a variable, and we have t determines, x is a function of t, and y is a function of t, right? They all depends on t minus 3, sorry, here, right? And then you get the point x comma y, and then you put the points together. And also, well, as we choose the value of t, okay, suppose I choose time is increasing, right? So for example, if I choose time as 0, and x will have a value, okay, y will have a value. Okay, and this point will be determined accordingly. When t is 0, right, t is replaced by 0, so that x is 0. So at time 0, x is 0, y is -3. So the point at time 0 is going to be 0, -3. And so on the other side, we're going to make a graph. Okay, we're going to make a graph. The graph is going to be made of points, okay, one by one, just like what we did before, but has an extra layer of calculation. Okay, so now I'm going to set up the rectangular system. Okay, so now we have a point. So I'm going to bring this up. Okay, and remove that. So with point 0, -3, and we know this is the point, you can imagine there's a particle. Okay, you can imagine there's a particle. And that point is at that location. Okay, let me make it red. Okay, so make it easier to see. So this is the idea of parametric graph, parametric curves or parametric functions. You can see the point x, y is determined on t. So now let's keep going when t, next moment, right, which is maybe 1 second later or 1 hour later, t would be equals to half times 1, right? Y would be equals to 1 minus 3, that's going to be equals to -2. So the next point, in the next moment, you can think of that way, 1, -2. So the next point is going to be right here, the red dot, right? And there's a sense of a direction. There's a sense of direction. So at one moment, the point is here, the particle is here. At the next moment, the particle moved over here. So there's a sense of direction. As t increases, the point is going into a certain direction. Okay. All right. So let's keep going and plot the next point. Plot the next point. And the next point would be, say, at 1 moment later, right? So we get these two functions, and the t will be replaced by 2. And this is divided by 2, replaced by 2. The point is going to be 1, -1, right? So this is equals to 1. And that point is going to be plotted on the picture right there. So the point goes up there. So you can see did I calculate it correctly? Moment 2, half times 2, 1, 2 minus 3, that's -1, right? So that's -1. Oh, okay. 2, 1, -1, okay? At moment 3, we will have these two functions, wait. Okay, so x equals to 3, right? T replaced by 3. And next one is, and that's 3/2, right? That's 3/2. And y is equals to 3 minus 3, that's equals to 0. So the next point is 3/2, 0, right? So we're going to put that point on the picture like that. Okay, you can see from moment to moment, the point is winding up. Can we calculate, say, t equals to 2.5, 3.1? Of course you can. Okay, so And this way you can see the graph has a sense of direction, Okay, so number 4, right? So let's try another point. So x is equals to half of t. T is 4, right? And half times 4 is 2, and y is equals to 4 minus 3, and that equals to 1. So the next point is 2, 1. So we're going to put 2, 1. Okay, so 2, 1 right there. So you can see that the particle, imagine there's a particle going up and up and up and going that way. Okay, I'm just checking if this point is in the right place. Okay, so at the moment 2, half times 2, t minus 3, 2 minus 3 is -1, and that's 2 times half equals 1. I think we're right. Okay, so this is how to graph parametrically. Okay, so in this kind of question, you would like to indicate the direction. We would like to indicate the direction. So let's see if I can use the software to mark the direction, right? From the first point to the next point, right? So we're going to connect the dots. You can connect the dots, right? The first point is 0, -3. The second point is 1, -2. Connecting these dots right there. Okay, so there should be a direction, but this software doesn't draw the arrow. So the next point would be that point, right? From the second point to the third point, 1, -1. So there's another connection. Okay, so you can connect the dots. So let's connect the dots. Okay, so first, second, third to fourth, right? Third to fourth. So from third to fourth, the third to fourth. So 1, -1, fourth, 3/2, 0. That's another line segment connected. So you connect these dots. So from fourth to fifth. So you keep going and connecting those dots. Okay, so that's going to make it 3/2, 0 to 2, 1, and that's another line segment. I'm not able to draw the arrow, but I have to use the Zoom software to draw the arrow. So let me make it a little thinner, right? So these arrows can be drawn, right? So these arrows can be drawn, telling us as time increases, the trajectory of certain particle is going alongside this trajectory. Roughly, because we don't know well, if you want to have more, you can just graph in between, right? Graph the points in between. Now, that's how we sketch the curve. Okay. They're usually a rectangular, we can get rid of the t algebraically. Okay, algebraically, we can get rid of the t, and and see and retain only x and y. So in that case, we're going to get an equation. Okay, we're going to get an equation, and this equation, say, if I get rid of the t, if I solve for only, we're going to eliminate the t. Okay, so algebraically, okay, we can remove the t, right? For example, from x equals to half of t, right? We can get t equals to 2 times x. You just multiply both sides by 2. And then replace the t in the second equation, okay? Then we substitute t by 2 times x in the second equation, in y equals to t minus 3. If we do that, t will be replaced by 2x. We ended up with a equation. This is actually a line equation, okay? But this line equation actually is not exactly this line we have, because we have this little turn here. We have this little turn here, right? So this is puzzling, and you wonder why. You wonder why, right? So we're gonna leave this question here and moving forward to do some more. So you can see in the process of getting rid of the t, we might lose some we might lose some features in the process. We might lose some features in the process. I was double checking whether this is correct. I actually don't see any problem that we did here. When t equals to 2, right? When it's equals to 1. Oh, I got it. I made a mistake here. This is a half. My bad. This is half. So this point is half. No wonder. That's why we saw that inconsistency. So half negative 2, that's the second point, my bad. Okay, half negative 2. Okay, so this should be half negative 2. This should make it. This should be right. Okay, so I made a mistake in the plot, in the calculation. I hope you guys, that's why I see why I didn't have that, right? Why I didn't have a straight line. So the next one, so that's, so the first point with the second point, that should be half negative 2. So this should be half negative 2. And the next point is, this is half negative 2. That would do it. That would do it. So that's the direction. So I made a mistake, okay? I made a mistake, now it's corrected, right? So these points are connected like this. So obviously that this graph is consistent, but this line, if you graph this line, you get exactly the same line. You get exactly the same line, okay? So I'm gonna graph this one, and I'm gonna put this graph side by side so we can compare the difference. We can compare the difference, okay? Hold on a second, okay? This is a graph, we get the rectangular system, so we compare with t or without t, the parametric. The two lines are definitively the same line, but parametric give you a sense of direction. So I'm going to change the scale. The scale is from, for this one, it's going to be from -5 to 5. Okay, to see if that will make it. Yeah. We will have all these points on the curve. So these are the same line. These are the same line, but with parametric, we have a sense of time. We have a sense of, we can vision the particle travel from one moment to the next moment, point by point, point by point. Okay, on this other one, then you don't have such a sense. Okay, you can go any direction you want. You can go any directions you want, right? So that's a difference between the parametric one and the non-parametric one. Okay, so this is something we learned before. So we still get the same line. It's just with parametric, we have the third parameter. Okay, T is called a parameter. Okay, so this T is called a parameter. And that parameter made the name into the kind of function we're talking about. Okay, that's the parameter. So let's look at another function. Okay, for any such kind of questions, we typically have the three questions that are related to it. Okay, the first question would be A. Okay, find the rectangular coordinate equation for the curve by elimination the parameter. Okay, that's what we did. Okay, we did it here. Okay, that's the part we did, eliminating, right? So our examples is we have done that. The second question typically is asking us to sketch the curve. Sketching the curve and indicating and indicate the direction of movement as t increases. So these are the two typical questions as t increases. So that's what we did, right? We did just that. I couldn't put the arrows in place, but we kind of pretended, right? These two softwares don't talk to each other. So at time 0, and the next moment, and the next moment, and the next moment. So this is the kind of graph you want to produce with parametric. So two questions. This tells you how to do your homework. This is how to do your homework. Okay. Next one, we're gonna do a few more examples. Okay. These few more examples. The next one we want to do is that we have a bunch of homework questions. So I'm going to choose different types. I'm going to choose some different types. Okay. These different types here, I want to choose for this one, we're going to choose this one, example number 2. Okay, so this question I have, this is parametric. We will choose e to the power t. Okay. Wait. Okay. X equals to e to the power t. Okay. And y is equals to e to the power of 2t. 2 times t. Okay. And of course, t is time. Okay, t is time. From one moment to the next moment. First, we're gonna answer the first question. The first question is that we want to find a rectangular, right? We want to do these two. Oops. Okay, we want to do these two categories. Oh, sorry. We want to do these two categories. Okay, the first one, we're going to eliminate the parameter t. So we have x equals to e to the power t, and y is equals to e to the power 2t. So what we can do, knowing that relationship, we can see e to the power 2t is equals to e to the power t, right? And square, that's e to the power 2t. And e to the power t is x, therefore is x squared. You see that? So it's really that y equals to x squared, and we know that curve for sure, right? We know that curve from the beginning, that example we did, right? So we know that curve. And so we know we're getting a parabola. We know we're getting a parabola. Okay, so this is a parabola. Okay, so now let's see how we're going to sketch the curve. We're going to sketch a curve. Does time have to start from 0? Well, time is a relative term. Time is really a relative term. So we're going to first set up our system. Okay, so we're going to set up a rectangular system. Right, so we have a t, we have x, we have y, and we have the points, right? We have the point. X equals to e to the power t, and y equals to e to the power 2t. So what do we see here, right? You can see when you draw that y equals to x squared, you get this curve, right? But if you look at the current parametric function, because e to the power t is always a positive and y is always a positive, I don't think we're getting the other half of the curve. We're not going to get this piece of the curve. We're only going to get the positive piece of the curve, because no matter what t is, e to the power t, e to the power 2t, these are going to be always positive. Okay, you know what I mean? So when t equals to, at t equals to 0, times 0, right? What do we get? Well, t actually can be any real number. Okay, time can be any real numbers. It's just a relative term, right? So if I do negative, so how do we do? We start from 0, right? And we come back to do the t equals to -2, -1. How about that? Okay, so we come back to it. So at time 0, e to the power t, right? So e to the power t, e to the power 0 is equals to 1. And this other one, e to the power 2t, is e to the power 2 times 0. And that's going to be equals to 1 too. So at the moment 0, we have 0.1, 1. Okay, so let's set up the rectangular system. Okay, we're going to set up the rectangular system and just make some adjustment. Remove that. Right, I'm going to make some adjustment to the view. So for now, we just set it up like that. When we need more, we'll put them in, we put them together. Okay, we just change the view. Okay, so the first point we get at moment 0, the point we have is 1, 1. 1, 1. So that's the red dot. 1, 1. Okay, so you wonder -1, -2, right? Let us do it. E to the power -1. So this is -1. And this is going to be e to the power of 2 times -1. So that's going to be e to the power -2, right? E to the power -2. They're both still positive. They're still both positive. Okay, so just e to the power -1. And this output is e to the power -2. And that point is going to have a position. Okay, so we're going to put it right there. It's a red dot right there. Okay, and -2, right? For -2. So I'm just going to take a little shortcut here. When t equals to -2, so this is -2, right? So this is -4. So the next point, okay, the moment before -1 is going to be e to the power of -2, e to the power of -4. And this point is going to be even closer to the origin. There, okay? But you can see that we will never be equals to negative. So this 0 is something we will never touch. So I'm going to make adjustment to the view because our picture is going to be only in the first quadrant. We will, shall we ever touch 0? Never, never. So for this reason, I'm going to put a circle. Okay, I'm going to put a circle at the origin, indicating that the points can be, you know, as t approaches -infinity, we get infinitely close to 0, but never touch 0. So the dots is going to go up like that. So only the half of, so the trajectory of a particle is not going to be the entire parabola. It's only part of it. It's only part of it. And there's a direction. Okay, there's a direction. And it has to start somewhere, right? So it starts somewhere. So this is the direction we're heading. One moment to the next. Okay, one moment to the next. Okay. And let's do a couple more points. Let's do a couple more points. Since we know the shape of the curve, right? So that should be pretty straightforward. So the next moment, right? E to the power of 1. That's e to the power 2. Oops, e to the power 2. So the next point is e, comma, oops, e comma, e squared. Okay, so this point is going to be on the curve. I think I will have to adjust. I have to make adjustment. Okay, it probably doesn't show there. No, it doesn't show. E squared is off the chart. Wait, yeah, it's off the chart. So I need to make some adjustment. Okay. Where's my e squared? E squared. E squared right there. You see the point was out of the chart, was off the chart. So let me make just a little bit adjustment over here. Right there, you can see the curve goes like that, okay? If we keep going, the next point, right? The next point is gonna be e to the power 2 in the next moment, and this is going to be e to the power 4. And that point is going to be e squared and e to the power 4. Okay, and I have to make adjustment to the view, right? And put the point on the chart. And there we go. Does it show the point? Yeah, it's still off the chart because e to the power 4 is like Yeah, we need to increase, right, to 27-ish. Hold on. So you can see, now you see all the points. Now we see all the points. Right there. Wait, let's see, where's my point? I think I need to make another adjustment because we have e to the power 2. So the 5 is not enough. Right, so put 8 there. This time it should include it. E squared. So make it 30. Let us estimate, right? What is e squared equal to? E squared is, it should be less than 9, but bigger than 8. Wait. So let me just change that to be 10. There should be another point. Okay, it's disappearing because I didn't pick the view properly. Okay, so let's resolve this issue once for all. Okay, e squared. Okay, give me the numerical value. Oops, give me the numerical value. And the e to the power 4, give me the numerical value. Oh, 54, that's why my estimate was too much, was not enough. I only have 30, that's why. Sorry about that, guys. So I need to make this 55. There we go. So this time we should see that point way up there, right? So I think that's enough, right? And next, you just have to indicate the direction, right? And what is more, since we know the general shape of the curve, so what you like to do is that you're going to just graph that curve on that piece. Okay, so it's going to be fitting. So the next one, I'm going to graph the x squares, it's going to fit in the curve, right? And on the curve, you're going to just put some arrows, like this, okay? So that will satisfy the requirement of your teacher. And that's it. So 2 parts, okay? For this kind of question, you have 2 parts. You need parametric for your calculus classes, but how do you graph them? And this is how you graph them, okay? All right, so let's do a trig. Let's do a question with trig parametric equations. Okay, so let me just remove those because these 2 softwares don't talk to each other. All right, example number 3. I think this is example number 3. Okay, and this one, of course, we still do these 2 things, right? Find the rectangular coordinate, and then do these 2 things, right? We need to do these 2 requirements, okay? And the function we have, the parametric function we have here is going to be like this, okay? 2 rows, just 1 column, okay? X is equals to cosine t, y is equals to sine t, and of course t is time. Okay, you can choose to do whichever one first. You can do A first or B first, right? It doesn't matter. So I'm going to do A first. So how do I eliminate the t, right? How do we do that? Well, recall that sine squared plus cosine squared is equals to 1, right? And cosine t is x, therefore we got y squared plus x squared equals 1. This is a unit circle. This is a unit circle. So we're getting a unit circle. We're getting a unit circle. Okay. Let's do the graph. Let's do the graph. Right? When we do the graph, we're gonna set up a table like similar to what we did before. Okay. And we shall use this opportunity to review trigonometry, right? So we got t, right? X equals to cosine t. Y equals to sine t. And we already know the hang of it, right? So x comma y. And we're gonna set up our rectangular system, right? Since we know we're getting a unit circle, and so we could just choose our rectangular system with a view fitting for a unit circle. And here we go. Okay, let me just clean up those decimal numbers on the axes, right? So we got our rectangular system. But how do we choose our time? How do we choose our time? That's the question, right? How do we choose our time? Well, how about special values? How about special, because the t are the input for cosine sine, right? And we can choose time. We don't have to, we can choose, say, time equals 0 and time equals to pi over 6, right? We can choose pi over 4, pi over 3. We're doing the counterclockwise. You can certainly do the clockwise, right? And pi over 2, pi over 2. Okay, so we're gonna do these 4 times, right? So at 0, cosine 0, right? So I'm gonna put these in place. Okay, the same function, you just have to substitute by different values. So for at 0, so t is replaced by 0, 0. And cosine 0 equals to 1, sine 0 equals to 0. So this point is 1, 0. The next one, pi over 6, right? So you can see we can plug in the time and get our points, Okay, so this is going to be √3 over 2. Right? Sine pi over 6 is 1/2. So we got 2 points already. So let's plot these 2 points first, okay, to see what we get. 1, 0, 1, 0. The dot, right? So what's the next one? 1 dot, second dot, second dot. So this curve, right? We're getting a unit circle, but in this direction, right? In this direction, it keeps going. So that's the circle we're about to get. So let's take the opportunity to plot the points, in the first quadrant, right? Pi over 4, pi over 4. If you like, you may like to pause and do your own, and then come back to see if you get the right answer, if you get the same answer. Maybe I made a mistake, right? If I made a mistake, please let me know. Okay, so the next point is going to be plotted there, and pi over 3, right? Pi over 3, and that's going to be half, and that's going to be root 3 over 2, right? So we got our, so that's going to be half. First quadrant is done, right? So you can almost anticipate what's to expect. And so I'm going to give you more points for you to calculate, right? See the points, right? And the next one on the first quadrant, you see in this case, using these special angles will help, right? It served the purpose. So this equals to 0 and that equals to 1. So the next point is 0, 1. There. Yeah, you can see half circle and the trajectory. If you imagine there's a particle, the particle at time 0 start to traverse, right? And the trajectory is from here all the way up and then going, right? So you can think of using those other values. So I'm going to give you a bunch of other values for you to calculate. Okay, and you guessed it. You can guess it, right? So the next point would be 2 pi over 3. The next one is 3 pi over 4. Those special angles, right? Which will make our life a bit easier. And the next one, of course, is pi. So the second quadrant is going to be done. Okay, it's going to be done, and we can keep going. Okay. And we already see the entire process in the first quadrant. So on the second quadrant, we're going to just continue to do that. Let's see how much time we have spent on this, right? I don't want to get you guys bored. Yeah, I think it's about time that we end this, right? So let's finish the second quadrant. I think you already get a glimpse of it, right? You have a glimpse of it. So let's just finish the second quadrant. So for 2 pi over 3, you can have a unit circle by your side, right? You can have a unit circle by your side, and cosine 2 pi over 3 is negative half. And sine 2 pi over 3 is root 3 over 2. Right? So we have a point that's negative half and root 3 over 2. Okay, so we're going to put this point on the graph. I'm going to put this point on the graph. Right there, right? So we keep going. 3 pi over 4 cosine 3 pi over 4 equals to negative root 2 over 2. And 3 pi over 4, that's going to be positive root 2 over 2. Right, so our point here is going to be negative and positive, root 2 over 2. So we got another point we can put on the chart. There. It takes a lot of patience, isn't it? Okay, so let me make the fonts just a little bit smaller, so this way we can see better. Okay, 5 pi over 6, right? Cosine 5 pi over 6, 5 pi over 6, and this value equals to negative root 3 over 2. And this value equals to positive half. And we got negative root 3 over 2, positive half, and we get another point on the graph. You can see the direction is pretty obvious. Right, the direction is very obvious. And the pi, cosine pi is negative 1. Sine pi is 0. Okay, so we get another point, which is negative 1, 0. So we put this point on the chart. There. Right, so half circle has finished. So from time 0, as t increases, right, so we get this half circle. We have this half circle. So if we connect these dots, right, if we connect these dots, so the trajectory is like, it's going to be like this. Right there. And we have a direction. We have a direction. Okay, so we can indicate the directions. That's what's wanted. Okay, so that is what's wanted. We have a quadrant 3 and quadrant 4. Since we're here, so how about we just finish together, right? How about we just finish together? I'm going to give you the values, and you're going to you can pause if you like, right? So I'm going to give you the values, which is 7 pi over 6, right? 5 pi. This is the perfect opportunity for us to review trigonometry and those special values, right? This is 4 pi over 3, and then 3 pi over 2, right? So that's 4 points in the third quadrant, and then we're gonna get 4 points in the last quadrant. Okay, so that's gonna be 5 pi over 3, right? And the next one is that 7 pi over 4. Okay, and that's going to be 11 pi over 6 and 2 pi. 2 pi. Okay, so let's finish. Let us finish. Okay, we can do this, right? Okay, you feel free to pause. Feel free to pause and do your own. Okay, so I'm just going to finish the whole 9 yards for one cycle. Of course, you can continue actually as time goes by. You can go around and round and round. That particle goes round and round and round. So it's cosine 7 pi over 6. And so this guy equals to negative root 3 over 2. Right? And the sine 7 pi over 6 is negative half. So our point is going to be negative root 3 over over 2, and the y value is -1/2. Okay, so we can put this point on the graph. Boom, right there, right? So one by one, we have a very good review of these special values. 5 pi over 4. So these are the cases you get -√2 over 2 for both. Okay, so I'm going to plot this point in the graph. In the graph. It takes some patience. It takes a lot of patience. Okay, we're doing it. We're doing it. And 4 pi over 3. 4 pi over 3 cosine 4 pi over 3, that's going to be equals to -1/2. Okay, and sine, that's going to be equals to -√3 over 2. -√3 over 2. So that point is going to be right there, right? So -√3 over 2, the y value, -1/2 is the x value. So we're going to put this point on the chart. There, right? So the circle is forming. And 3 pi over 2 for cosine, that's equal to 0. For sine, equals to -1. So the point is 0, -1. 5 pi over 3. 5 pi over 3. In this quadrant, this is quadrant number 4, and this is going to be half positive. Okay, sine is going to be -√3 over 2. So our point, we're almost done, guys. Let's finish it, okay? You should not be surprised. I might quiz you, right? I might quiz you. 1/2, so this point. Oh, we didn't graph this one, right? We didn't put that point on the graph, so let's do it. For there, right? 0, -1, and half, -√3 over 2. Just a few more points, just a few more points. We're almost there, 7 pi over 4. And this is sine 7 pi over 4. This is going to be -√2 over 2. And cosine 7 pi over 4 is, so this is going to be √2 over 2. -√2 over 2. Okay, I'm just being careful. We're almost there. We're almost there. Okay, so point by point, we're doing it. Right? It's not that hard, isn't it? It's not that hard. You can do it too. You can do it too. So please do it. And this time it's going to be √3 over 2. And that piece is -1/2. So we got our point, right? √3 over 2, -1/2. one last point, okay? We'll, and of course the particle will continue moving, right? Cosine 2 pi is 1, sine 2 pi is 0. And we get 1, 0. We're back to the, we are back. So we're back to the original point. And if the time keeps going on, the particle will keep traveling around and round, right? So that's going to be what we're getting. Okay, so the full circle, and we can put the directions in place. Okay, it's a counterclockwise. Okay, so I think this lecture is long enough. Thank you for watching. Until next time, thank you for watching. Bye.